An ellipse can be thought of two ways. It can be thought of as a slice of a cone, or it can be thought of as a string attached to 2 points. These points are called foci. That's the plural. You can also call them each individually a focus. They are the focus of the ellipse. So the length of the string will never change, and as we go along, we'll see the sum of one piece of the string to the pencil plus the other piece of the string from the focus to the pencil is always going to be the same. As we go along, the sum of the string always adds up to be the same amount, and that's how we create our ellipse. So our ultimate goal with this video is we're going to take an ellipse and we're going to figure out the equation of an ellipse centered at the origin. And if we can find the equation of an ellipse, then we can use that to work with it and graph any ellipse we want. So we're going to imagine we have that piece of string going to a random point on the ellipse. Since it's a random point, we don't know the exact values. We're going to call this x, y. And I'm going to call it point P so that we can talk about it. So the distance from the first focus, focus 1, to P, so that's the longer length of the string and what I've drawn, plus the length of the string from focus 2 to point P, that would equal the same distance anywhere else on the ellipse. So I'm going to choose the second one a little more cleverly. I'm going to choose from the focus straight over to the A and this first focus over to the A. So since the distance from the center to C goes on then to A, we could actually imagine the smaller string on the other side, and the string actually then ends up being the entire length along that major axis. Since we've labeled to the point as A, then the distance in the other direction is also A, and A plus A will give us 2A. So now here's where things get a little more complicated. To find the distance on a line, we have to use the distance formula. So distance formula is square root of x2 minus x1, the x values squared, plus the y values squared. So we're going to do x values for the first focus, and then we'll go on to the second. So first focus, we're going to have square root of x minus negative c. That will change this to a plus c. Distance formula is adding the two things squared. Now we do the y values, y minus 0 squared. I'm going to have to move the equals 2a over because I'm going to run out of room. So then we want to add the distance from the second focus to the point. We use distance formula again. This time we use x minus a, we're going to the focus, not to the vertex, x minus c instead of the x minus negative c. So this will be negative x minus c squared plus, and then it's y minus 0 again. Both of these had a y value of 0. And I still ran out of room. I'm going to completely erase the equals 2a. Now, to simplify this down to be a formula that's usable for us actually requires a lot of algebra. When you go through, there's a lot of squaring and factoring, but taking the fact that this first distance plus this second distance equals 2a, you can actually go through and eventually it becomes the formula for an ellipse, x squared over a squared plus y squared over b squared equals 1. And this is the most convenient formula for an ellipse centered at the origin. We're not going to work with ellipses centered anywhere else. So when it's centered at the origin, we notice that A, that's that major axis, but only half the length. The entire length is 2A, half the length is A. B is the minor axis, so half the length of B, or sorry, half the length of 2B is just that B. So now that we have this formula for an ellipse, we're going to now see how we use it to create the picture for an ellipse, or given a picture, how we can write out the formula for it.